Kinetic energy is dependent on the speed and mass an object has. In fact, the object's kinetic energy store is directly proportional to the square of its speed. From this, the kinetic energy equation can be derived, and it is as follows. Kinetic energy, which is measured in joules, equals a half times the object's mass, which is measured in kilograms, times by the speed of an object squared, which is measured in meters per second squared. Moving on to gravitational potential energy stores, or GPE, every time you lift an object above the ground you do work. Your muscles transfer chemical energy store into gravitational potential energy store. The force you need to lift an object is equal but opposite to the gravitational force on the object, provided the velocity is constant. The gravitational force is known as the object's weight. So if you wanted to lift an object of weight 60 newtons, you would have to use a force of 60 newtons. Some key points to note are: when the object is moved upwards, its gravitational potential energy store increases. This increase is equal to the work done on it by the lifting force to overcome the gravitational force, or its weight. When the object moves downwards, its gravitational potential energy store decreases. The decrease is equal to the work done by the gravitational force, or its weight, acting upon it. The work done is lifting or letting down an object depends on its weight and the distance above the ground it's travelled. Using work done equals force multiplied by the distance moved in the direction of the force, we can derive an equation for gravitational potential energy store. The change in an object's gravitational potential energy store, which is measured in joules, equals the weight measured in newtons multiplied by the change in height, which is measured in meters. Now we'll look at a situation if the gravitational field strength was larger. We know that the weight of an object in newtons is equal to the mass multiplied by the gravitational field strength. We can use this to calculate the change of gravitational potential energy store in different gravitational fields by using the following equation. Change in gravitational potential energy store, measured in joules, equals its mass, which is measured in kilograms, multiplied by the gravitational field strength measured in newtons per kilogram, multiplied by the change in height measured in meters. This explains why objects would be harder to pick up in a larger gravitational field. The final type of energy store we're going to look at today is elastic potential energy store. As we already know, when we stretch a rubber or a spring, the work done is stored as elastic potential energy. If the material obeys Hooke's law, then the force applied will be directly proportional to the extension. Hooke's law states that the force applied is directly proportional to the extension of the material up until a certain point. As an equation, force equals extension multiplied by the spring constant. The spring constant is different for each material. Using Hooke's law, we can make an equation for elastic potential energy. This is the elastic potential energy measured in joules equals a half times by the spring constant K measured in newtons per metre times by the extension squared measured in meters squared.